Dear student, I am Abhishek. Today we discuss the class 11 topic that is very important chapter gravitation. This chapter is very important for your NEET as well as JEE examination. So we see the topic wise this chapter. I divide this chapter into total 13 topic. That is very important topic. And according to topic, we go ahead with a detailed explanation as well as PYQ. So the first and the most important topic is that is Newton formula. This topic is very important. In the last decade, we see that from this topic, so the first and the most important topic is Newton formula. So in the last decade, we see that from this topic, that is Newton formula, many question asks. So this is important for a NEET as well as JEE examination also. The second topic is acceleration due to gravity. The third topic is type of G varying. This means G will varying by the four method. Actually, total four method is there. Suppose that there is GH, that means if there is a earth, then above the earth the gravity will be vary. If GD means if there is a earth, then from the surface of earth below the earth surface the gravity will be decreases or something changes like that will differ from 9.9.81 to something different value. Now third part is due to shape of earth, and the fourth part is due to axial rotation of earth. That means we know that ki earth is also rotate axially from their own axis, and one is around the sun, right? So there's the two type of rotation of earth. Now next topic is the fourth topic is that is gravitational field and gravitational field strength. This topic is also very important. Okay, and the fifth topic is that is gravitational potential, and the sixth topic is relation between field, that is gravitational field, and potential, that is gravitational potential. We're talking about the relation between both. This relation is very important because many question asked in the previous year with this relation also, and there is a graph in this relation that is also important for your examinations. Now the next topic is gravitational potential energy. Now gravitational potential energy topic is important for like numerical purpose. Mostly in satellite numerical this topic are used. Okay, now the next topic is the eighth and the most important topic is binding energy. In this topic we discuss how the and how much energy is required to bind something with gravity, to hold something with gravity. So this topic is also very important for us. And the next topic is that is escape velocity. In this topic we learned that what is the minimum velocity required to hold like to throw something so that they never return to the earth gravity. So this is the escape velocity. And the next topic is 10th, that is motion of satellite. So after the escape velocity we are going with the satellite part, and there is two type of satellite, that is one is geostationary and second is polar satellite. We go further like detail in this topic, right? And the next topic is that is most important topic, Kepler law of planetary motion. This topic is also like a star mark topic, and from this topic many question asked in previous year. All laws are important, you all know, like. And the 12th topic is, that is energy equation. That is energy equation, that is all kinetic energy, potential energy, and total energy, and its graph. So according to JE syllabus and NEET syllabus, this topic are most important. And the one small topic also, let's just say include here, that is energy equation with numerical approach. Means we learned this energy equation. By the energy equation, in this part, this is the theoretical part, and then we go with the graph part, and after that we see that how we use this energy equation in the case of numerical part. So first is Newton's formula. Just formula. Okay, now what Newton says that, if there is a two mass m1 and m2 at some distance, that is distance will be r. Newton says that some distance, that distance will be r, then there is a force of attraction between them, and that attraction force will be, they say that the F force, the force is proportional to product of their masses. First equation. Second equation, they said that the force is inversely proportional to a square of distance between them. If you merge from first and second equation, we got that F proportional to m1 m2 upon r square. Okay, this is the formula, and by this formula we got F is equal to G m1 m2 by r square. Okay, this is the formula of Newton's, which is given by Newton's. Here G is the universal gravitational constant, and the value of G is 6.67 into 10 power minus 11 Newton meter square kg square. Now from where this value, I said that from where this unit comes out. So if you expand this formula, so the G is equal to F into R square. This G become F into R square by m1 m2, and by this way you got the F is Newton, the R square is meter square, and this is kg square. So that's why this formula comes out from here. Now why I am writing this, because I want the dimension formula of G. So if you write the dimension formula, then you write kg meter per second square into meter square divide upon kg square. So kg cancel out here. Okay, and this formula become meter cube kg second square. Okay, this is the formula. So if you write the dimension formula of G, that is mlt. Okay, so the m is -1, l is 3, and t is -2. So this is the dimension formula of G. This question mostly asks in NEET exam. Okay, so I consider both exam, and that, and then the lecture is going on. Okay, no issue about that. Now second part is, the second topic is, first topic will be cover here. Second topic is acceleration due to gravity. Okay, in this chapter we know that just now we know that the formula of this F. Okay, so we use this formula. We know that according to Newton second law. Okay, what we know that, suppose this is the earth, okay, and there is a mass m, and if the ball is dropping here, है ना, so A is equal to G, because this is a free fall. So free fall में A is equal to G होता है बच्चों, and this is the earth. Okay, if the ball is dropping downward, then this is the free fall case. Free fall case, then A is equal to G. According to Newton's second law, we know that F is equal to ma, that is m into G. Okay, this is the formula. So in this formula, what we are doing here, we are finding the gravitation value of G from where the G is comes out. Okay, so we are solving the formula. So we know that right now we know that F is equal to G m small m by, this is a small m, and the capital M is the mass of earth, small m is the mass of object. So G mm by r square. Why r square? So this distance become r. Okay, suppose that this is r, or फिर I write small r because capital R mostly denoted the radius of the earth. So I write small r so that you got a clear understanding here, right? This value. Now if we know that this formula, okay, so what is the value of G here? What is the value of G here? So G is equal to F by m by this formula. So we write this equation 1, this is one equation and this is two equation. So we write equation 2 here. So this is the G capital M small m by r square upon m. So m cancel out, so this value become Gm by r square. So we know that G is equal to Gm by r square. Okay, this is the second formula, and by this formula you got the value of G, that is G is equal to 9.81 meter per second square. Okay, this is the G value. Already I discussed G value. G is the gravitational constant. Okay, m is the mass of earth. Okay, m is the mass of earth and r is the distance. R is the distance. Okay, these are the main function, main formula of this question. Okay, now if you go ahead with the variation of G, so this is the main concept. By this concept the many PYQ question asked in the previous year. So variation in value of G. So this variation are of four type. Okay, the variation is due to first, due to shape of earth. The shape of earth is not spherical, that's why this variation of G's comes out. First is height. Second point is height above the earth surface. Matlab, if you go upward from the earth surface, then the gravity will be changes. One by one we'll discuss this thing, don't worry about that. Okay, just I write the like topic here. Okay, third point is depth below the surface on the depth below the surface on the earth. Okay, and fourth point is axial rotation of the earth. These are the 4 points, and all points are discussed one by one, don't worry about this. So first topic is shape of earth. Now what about in this topic? Okay, so the first point is the earth is not a perfect sphere. Earth is not a perfect sphere means flat at two poles. Flat at two poles. What this mean? This mean that the earth is, we assume that earth is like this. Okay, but earth is not like this. Earth has become like this. Oh, not like, just like this. like apple shape. Earth is like this. So the this radius become this diameter become less than this diameter. Okay, so the second point, this is we assume. Okay, and this is the actual earth. Okay, so that's why the radius become this radius become r plus the radius become r plus 21 kilometer. This radius become r plus 21 kilometer more. Okay, and this radius become only r, smaller. Okay, now if you're talking about second point, the equatorial radius is approx 21 kilometer more than the polar radius. So this is already I explained you here. The equatorial radius become 21 kilometer because this diameter is more. Okay, so that's why in the circular shape the everywhere diameter is same and radius is same, but in this case this is the maximum. So in this case the value of g become similar, which we derive right now, that is g m by r square. This is the formula. Okay, this is the formula. Just this is the formula. Okay, now so g minimum at equator, okay, and g maximum at pole. So in the case of earth, here is the g maximum, here is the in this equatorial point, in this equatorial plane there is a g minimum. At the center of the earth g is 0. Okay, these are the point. Now if you're talking about the second part, first part is covered here. If you're talking about the second part and case 2, this is case 1. Okay, case 1 that is completed, case 2 is started. Okay, so case 2, height above the surface of earth. If you go with the height above the surface of earth, suppose that this is the earth. Okay, and in the earth we assume that spherical, we assume right now spherical. Okay, now there is a mass m, okay, a small m, that is at height h from the surface of earth. Okay, the height h some from the surface, and this is the radius of earth. So if we add this whole length, then r is equal to how much? That is h plus re. This is the total value. Okay, so what we are writing here, the force is same just like in previous, that is g m by r square. The value is g m by re plus h ka square. That is re is the radius of earth, that is 6400 kilometer as of now data. Okay, now and the h is depend on at what height the earth the particle will be. Okay, so if we find the value of g, gravity at this point, so if you go with the formula only, so we got the value of g h is equal to f by m. We know the formula. Okay, so g m small m upon m into r plus h ka square, and this value become g m by r plus h ka whole square. Okay, just I write clearly here, r plus h ka whole square, m cancel out, so we can write g m into r plus h minus 2. Now this is the binomial equation form. So if you break the binomial equation, then after binomial equation breaking, we got the value, that is g uh, g plus g into 2h by r. Okay, sorry, not plus, this is minus. Okay, this minus. So you if you got the G common, then we got G 1 minus 2h by r. This is the formula, and this is a very important formula because many PYQ asks on this formula. So if you don't know anything in the gravitation, then if you learn this formula also, then you are able to solve many question of PYQ. Even though next session also, I hope so, the same formula is used to solve many type of numerical. Okay, so these are the gravity equation at the height h. Okay, if this condition here, if h is less than re, that is the radius of earth. So this is the second case formula. Okay, and if we're talking about the third case formula, two cases are covered here. Okay, third case part means, and the gravity is case third. Okay, third case. So the depth formula, depth below the surface of earth, depth below the surface of earth. In this case, what is going on? Suppose there is earth. Okay, and under the earth the particle is coming. This is the radius, this is the center, this is the radius. Particle is coming till here. Suppose that particle is digging in the earth and they come to the depth d, and this is the radius of earth. Okay, so what is the gravity formula at the depth below the earth? The formula, just you know the formula, because the similar pattern, same mathematical equation comes out and this derivation is bilkul same as it is same. So diameter depth formula is 1 into 1 minus d by r. This formula become this 1 into 1 minus d by r. Okay, and in this case we can say that the gravity formula become 1 minus d by r. So there's a two formula, there's two is very different. So we see this now how the gravity will be vary. Firstly we see this, in this case the gravitational force will be same as like we are finding previously. Like in this case the gravitational force g minus this value means this, when you go to the height h. Okay, when you go to the height h on the from the surface of earth. Okay, when you go to the height edge from the surface of earth, then definitely your gravity will be decreases. And third part is when you this g minus this value. Okay, so when you go under the earth towards the center, okay, then at the center gravity will be zero. Then definitely this point is this point having the maximum gravity. Okay, the if gravity will be zero, maximum from maximum to zero, then definitely the value of gravity will be decreasing. So if you go downward to the earth by digging, then your gravity will be zero. This says that the change in gravity. Now third part is the very most important part, that is the fourth part is, that is the axial rotation of earth. The axial rotation of earth, what this mean? That suppose this is the sun. Okay, and around sun we know that in elliptical orbit, okay, according to Kepler law also, the earth will be moving. Okay, the sun is not in center right now, I am making in center, not in center, at the focus. Okay, this is the ellipse, this is the elliptical shape, and the one focus having the sun is, okay, and this everything is moving. Okay, but the earth having two axes, one is this way, and second is their own axis, along axis, है ना, this axis. Now the formula of this axial rotation is g dash equal to g minus r omega square cos square phi. Okay, what this mean? This is the gravity formula. Okay, and this is due to axial rotation, and this is due to gravity. This is the formula. Okay, so if the axial rotation of earth is this, if you remove the axial rotation, suppose at equator, okay, at equator, if phi is equal to 0 degree, okay, at that time g dash equal to how much? G dash equal to g minus r omega square, because cos 0 become 1. So the value will be minimum. So g is minimum here. Okay, now at pole means the phi become 90 degree. Okay, the pole, if I draw this, so this is the pole, north pole and south pole, this one, and this become the equator. Okay, so at pole the value of g dash become g minus r omega square cos square phi. Then the cos 90 will be 0. So this value becomes 0. So g dash equal to g. So that's why I am saying the g is maximum at pole. Now one mostly is question asked in NEET exam or in other competitive exam also कि if the axial rotation of earth मतलब this rotation of earth will be stopped. If this is stopped, then what happen in gravity? If the axial rotation of earth is stopped, then this value become just now I'm writing in the this side. If the in a note case, okay, note, okay, if the axial rotation of earth stop, then what happen on g? What is the effect on g? Yeah, what happen on g? So the axial rotation g dash become g minus r omega cos square phi. This is the formula. Okay, in this case if the axial rotation becomes stop, what this mean? This means that this value become 0. So if this value becomes 0, then d just equal to g. What this mean? This mean that the gravity on the earth at the pole, that g is the 9.87 this value, and at the equator that is 9.67. Okay, and in this part 9.81. This is the gravity. This is the gravity value. At the equator gravity becomes 0. So when you go from downward to upward, the gravity value will be decreasing. Okay, the gravity value the gravity value is decreasing. So we can say that the gravity will vary according to the place to place on the earth. But if the axial rotation of earth becomes 0, then the gravity become what? G. Means the gravity g will same everywhere on earth surface. On earth surface, these are the four case. And the gravity, this is a PhD on the gravity part, like according to like class 11 syllabus, we got the ample amount of knowledge by this lecture. Okay, and this is all about for today because we cover the first section of the part. Okay, and from the next section we go ahead with the general like a general electric field or the field strength and something else. Suppose just I give you the some basic idea about the field, then you understand I think better. Now the next topic is gravitational field. After this topic we rewind the chapter. Okay, that is E or G or I. This is represented by three part. Gravitational field strength means what is the strength of gravity, what is the capacity of gravity. So how to find capacity? G is equal to I is equal to E. That is represented in many different book with the different like symbols. So we can write this, that the formula is again F by M, because we know that F is equal to M into A, that is mg. So from this formula this become this, right? So this become g m by r square into m. So m cancel out, so g m by r square. The formula will be same. So g is equal to how much? G m by r square. The strength of gravity field will be same everywhere. Okay, and the direction of field will be E. If you write this, E is equal to gm by r square. Okay, now this is r square, and the field due to point mass and direction towards center. Suppose this is a point mass, okay, O point, and there is a point P, and there is a field E, okay, and the distance will be r. Then this is due to this mass. Okay, this is G, not H. This will be okay. This is the formula. So this is the all about of today lectures. From the next lecture we are going on the next topic, and that is the important topic, That is a little bit like different one from this part. So this is all about for today. Thank you for this session, and just you revise all the formula, make a short notes of this formula, and definitely we you are able to solve many pyq on this part. I said that, from this part you got at least one question in in every year. Okay, this is the main part of this is the core part of this chapter. And one is satellite part. One is satellite part. Okay, one is satellite part. This is the main two part, and from this part definitely you got one question. If the question comes from the gravity, then definitely you got one question from this part and one question from the satellite part. Most of the time we see this pattern, and by this way you are able to crack the exam with main effort, like minimum effort and maximum output. Okay, thank you for today. Okay, bye.